Okay. So today I will be giving you what is actually required for the analysis and for preparation of the paper. Okay. And what are the testing you have to do. Okay. And what are the after the testing, what kind of analysis you have to do and what are the graphs are required. Okay. The entire actually we need not only with only one method, we need many methods. So there are two cases actually we have discussed. First one is for continuous data, and another one is for the that is a binary data set, or that is I'm talking about the outcome variables only. Okay, so just let us share the page now. Some of you already have worked on some data sets, and you already sent some papers with me. Sorry, analysis with me. Okay, please tell me whether the screen is visible or not. Screen visible to all of you? Okay. Okay. So basically, we are talking about the output data sets. Okay. Let us suppose the that is I have shared or I will share different data sets to you. First, one kind of data set is the data sets. Suppose the design variables are like this: x1, x2, x3, and this is the y, which is the outcome. Okay, this is data set one. Another data set is x1, y, x2, x3, and so on, and y outcome. Okay, in one case, these outcome variables, this is continuous, and another case, the outcome variable is either discrete or you can say not only discrete, you can say it is multinomial or it is categorical basically. Okay, categorical. Categorical means there are some categories are there. In categorical data sets, the examples you can see those who have got the data set of biomedical engineering. Okay, in case of biomedical data sets, these Y variables, it is categorical. Let us suppose only yes or no. Okay, yes, no, yes, yes, like this. And in case of some aircraft data set, or some other kind of or sensors or like this kind of data set or air pollution data set, these data sets the outcome variable may be continuous. In that case the outcome variable, if suppose we are talking about the pollution, air pollution, then the carbon emission is represented by the outcome variable. So carbon emission is represented by the outcome variable, so carbon emission is not a categorical. The carbon emission, it gets a value. Okay, let us suppose it is 1 metric ton. Okay, 5.2 metric tons. Okay, 10 metric tons, 3 metric tons, and so on. Based on these different x1, x2, these are the design variables. Okay, so x1, x2, x3, these are the design variables, and these x1, x2, these are the design variables. Design variables may be anything, maybe categorical, maybe continuous, but our focus is to only concentrate on the outcome variables, whether it is continuous or whether it is categorical. Okay. In continuous case, generally we will be apply the regression analysis. Okay. And in categorical, we will be applying the classification. Okay. So this what kind of analysis we will do? If you are having the continuous data set, only I'm talking about the outcome variables. If the outcome variable is continuous, use regression. If the outcome variable is categorical, use classification. Okay. Now in classification, yes, regression is also there, but that regression is logistic regression or multinomial regression you can apply. But this regression, it is a continuous variable regression. There is a regression model will be formed, maybe linear or non-linear regression. Okay. So those who are having the outcome variable as continuous data set, okay, use the regression analysis, linear or non-linear. Based on which regression analysis there is, what we will be testing for this. We will be validating with the R squared value. Okay, R square value, adjusted R square value. Okay, and the p value and the error analysis. Okay, these are the parameters which we will be checking after the model integration. Okay, if the model after creating the model. Okay, so you use the regression if in case of continuous data, these R squared, adjusted R squared, p value, you'll be checking this. Okay, based on these values, you can understand that the regression model fits the best or not, is the best fit regression model or not. Okay, so remember what I'm saying. So in case of regression, use these values, adjusted R square, p value, R square and p value. Okay. And after that, for error analysis, okay, you can use, okay, the mean squared error, okay, the root mean squared error, etc. Okay. Generally, RMSE and MSE we will apply for error analysis in case of regression. Understood? And in okay, before regression analysis, one thing you must notice that before the regression analysis, you also find the correlation matrix. So correlation matrix is the foremost means priority correlation matrix or design variables. Okay, correlation matrix for the design variables. Why correlation matrix is needed? Because we have to understand whether there is any auto correlation exist between the design variables or not. So auto correlation between design variables are x1, x2. I'm not talking about the outcome variable. Okay, the independent variables x1, x2, x3, and xn. Okay, so if the correlation matrix, if there are any two design variables, let us suppose x1 and x3. So x1 variable and x3 variable has a very high correlation, then any one of them, either x1 or x3, you have to delete. Because if the design variables has very high correlation between them, okay, the model, we should not get the proper means best fit model for that. Understood? So correlation matrix is very necessary for that. If you are getting very high correlation between any two variables, design variables, then any one of them must be deleted. Okay. And next one is these are the analysis we need to do for regression. Now come to the classification. So in case of classification, what we need first, we need that is after the classification model. Classification has different kinds of classification means cases are there. You can apply the KNN, okay, support vector machine, ANN, artificial neural network, okay, and logistic regression, okay, XVG, okay. So these are decision tree and random forest. These are the different ML techniques are available in case of means categorical or classification. Okay, so in case of classification, you have to apply all of them. Okay, so any one of them, let us suppose that means after applying these methods. After applying these methods, what are the results we need? So after applying the methods means you can use some testing dataset, means the whole dataset is given. A percentage of dataset you can use for testing, sorry, for training. Okay. Some percentage is used for testing. Percentage used. Okay. So what are the analysis we need? Okay. Now I'm talking about the classification case. So in case of classification, the analysis we need, the first one is the most important, that is called confusion matrix. Okay. So what is confusion matrix? Just I'm giving you, okay, just let me ask that what confusion matrix is. Anybody know what is confusion matrix? If you know the confusion matrix, please write down in the chat box. Yes, you know it. Okay. Amit Kumar knows what is confusion matrix. Anybody else? Yes, exactly. So the actual correct, true positive, true negative. Okay, or actual correct and predicted correct. Okay, so similar to statistical method, which is called the type 1 and type 2 error. Similar to this, which is used in statistical hypothesis. Okay, okay. Anybody else? Amit Kumar and Visha, they know what is confusion matrix. Anybody else? Okay, so I assume that other than Amit and Visha, there nobody else know what is confusion matrix. Let me. Okay, Deepak also knows predicted values. Exactly. Right. Yes, you are right. So let me explain a little bit. So you need to obtain the confusion matrix, okay, based on the data sets. So I will share a paper with you, and you will also do the exactly same thing, okay, exact same analysis. And after that, after completion of the all the analysis, you have to make a dashboard. Means you have to make a software. Okay, so will be that software, making of the software will be our innovation. Okay, exactly the same kind of paper I have downloaded from the internet. I will show you the paper, and after just reading the paper, you can understand that what we are actually need, what is actually needed, and exactly the same thing you also have to do, and have to create a dashboard. Okay, what kind of dashboard? Just the analysis dashboard which can create a confusion matrix. Just in that dashboard, you have to just put the data set, and after putting the data set, that data set will create a confusion matrix, and after the confusion matrix, all the error analysis. Okay, and after that, the necessary graphs will be automatically created by the dashboard. Understood? And that will be our paper. Okay, that will be our innovation. So let me just give you a small explanation of. Okay, confusion matrix. Let us suppose. Okay, I'm using a very small example from internet. Okay, to just make you understand what confusion matrix is. Okay, so just let me use this data set. Yes, this one. Is it visible to you? Screen visible to all of you?
Yes, sir.
Okay. So you can see that this is a very small data set, and this data set, this is actual and predicted. Okay, so our data set was given, this is a result. Okay, after using any kind of ML technique, let us suppose we have used the ML technique like logistic regression, suppose. Okay, after using the logistic regression, this was, you can see this is a binary data, dog and not dog. Just whether what is the outcome variable? Our outcome variable is only yes or no. That is dog or not dog. This is the outcome variables. There are many x1, x2, x3, many input variables are there. So if it is dog, then we will write yes, not dog, no. So yes, yes, no, no, and whatever. Okay. So you can see the first one, the actual is dog, predicted is also dog. So actual and predicted are matched. If they are matched, we will say it is true positive. Okay. Now it is dog, not dog, not matched. So in case of not matched, now what is actual? It is dog, and predicted is not dog. So we will say it false. Not matched means we will first say it is a false, and false negative. Okay, because we are predicting not a dog. Okay, so it is false and negative. Third one, dog, dog. Of course, it is again false, false, true, positive. Matching, if it is matched, then always it is true. If it is not matched, then always it is false. Okay. Now there are two cases: false positive, sorry, true positive, true negative, false positive, false negative. Okay. Now later, why? Now let's look at this. What is actual? Not dog. What is predicted? This is also not dog. Okay. So what we can say, since they both are matched, so we will say it is a true. But true positive or true negative? Because it is both a not dog, it is true negative. Okay. Next one, dog, dog. Of course, it is true positive, not dog, dog. It is not dog and dog. False positive. Why? Because our predicted is dog. Okay. And actual is not dog. Predicted is dog. So that is why it is false but positive. Okay. So it is true positive, true negative, true negative. Understood? So now what is the confusion matrix? So a confusion matrix, it is a matrix of actual and predicted value. Okay, so how many actual value are means correctly predicted? Okay, and how many false positive correctly predicted? How many false negative correctly? Sorry, true positive correctly predicted, and how many false positive correctly predicted? Okay, so this is actually just let me copy and paste the matrix. You can easily understand. Okay, so this is a confusion matrix. So predicted and actual cases. Just let me. Okay, look at this. So true positive, true negative. So dog and dog. So how many true positives values is there? One. Okay, one, two, three, four, five. So five true positive values. So it is this cell of the matrix. It is five. Next, dog and not dog. That is, it is false positive. How many false positive values are there? False positive is one, one only. Okay, one. So in the second cell of the matrix, that is, it is 1 to cell, it is the value is 1. Now how many false negative values are there? One, only one, right? One. And how many true negative values are there? True negative, one, two, three. Three. Understood? So this is our uh, confusion matrix. So what is confusion matrix? The confusion matrix is this: 5, 1, 1, 3. Okay. Always remember these two diagonal. There is a reverse diagonal. That is, these two cells must have the bigger values than these two cells. Then we can say that yes, model is right. Okay, model is predicted correctly. Otherwise, if these values are very high and these two values are lesser than this, then our model is not a good model at all. Okay, not good model. It is a means worst model, we can say. Understood, everybody? What is true positive, true negative, and this matrix we need. Okay. Python code is also there. So I will also show the Python code, that is how to, what kind of packages should be installed there. Okay. And how to create this matrix. Okay. After that, what are the analysis we have to do? The analysis is, there are some kind of error analysis. I'm writing these analysis. You must do these analysis also. After creating this matrix, that is confusion matrix. Okay. These are the errors, means matrices. There are some matrices, or accuracy analysis, precision. What is the accuracy? What is the precision? Okay, what is F1 score? Okay, many things are there. What is recall? We need to also predict that one, means calculate that one. So what are the calculation? Accuracy. First one is accuracy. Okay, precision. Okay, F1 score. Okay, and the other things are recall, and specificity. Okay. And six, another one is also there, which is called type 1 and type 2 error. Okay. Formulas, you can all, the formulas are available in the internet. Okay. Just the formulas are based on this true positive, the number of true positive, number of false positive, number of false negative, and number of true negative. Exactly, based on these numbers, the formulas are created. Okay, use those formulas, available, freely available in the internet. Any means website, you can see these accuracies. These all these matrices you can find. Okay. Otherwise, the in Python, all these formula that easily you can obtain. Okay, just by using one command, all these matrices are obtained. Okay, so I am showing one means the same thing. I'm showing in MATLAB, sorry, Python Jupyter Notebook. Let me share the screen. Okay, TP, NP, FP, and FN can only be used to denote the binary one. Yes, no, 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 no. For non-binary cases, means categorical. Let us suppose the data is categorical but not binary, means non-binary case. More than three or four categories are there. In that case, also three cases, you can also use this TPNP FPFN. Okay, that is also possible, and that confusion matrix is also can be created. But mostly in case of our data set, Deepak, will you say something? Not. Okay, then please mute yourself. Yes. Okay, so for non-binary cases also, confusion matrix can be created. Okay, confusion matrix can be created for binary and non-binary both cases. Okay, you can also see the method available to the internet, but I am using the binary because most of the biomedical or most of the cases where the categorical data are there. So generally, the binary data set is given. Okay, non-binary, very few non-binary data set are given in some cases. Okay, yes, true positive and true negative. true positive, true negative can be used. Okay. There is an example also. Okay. Look, just I'm giving one example. Look at this example. This one. Can you see the board? There are three categories: cat, dog, and horse. In that case, so okay, cat, cat, true positive, cat, dog, true, false positive, cat, horse, false negative. Okay, dog, cat, false positive. You can see cat, dog, okay, and dog, cat. Both are false positive. Okay, dog, dog, true positive, dog, horse, false negative. Okay, cat, horse, false negative. Okay, so in case of horse, you can use false negative for both cases. Cat, horse, also false negative. Dog, horse, also false negative. Okay, horse, cat, false negative. Since cat, horse is false negative, horse, cat, of course, it is false negative. Okay, horse, dog, false positive, and horse, horse, of course, it is true positive. Understood? Now understood? Okay. So now let me give you the example of means the Jupyter notebook. I think you are using the Jupyter notebook as it is easier to use. So let me share the screen. Screen visible to all of you? Okay. So this is the matrix, the very means basic one I'm just giving you, just to show you that how it works in Jupyter Notebook. Okay. Uh, First of all, this Seaborn, it is not installed in Jupyter Notebook. In my case, I don't know if you are using the Anaconda. Okay, in Anaconda, I think PIP you should not use that, and Anaconda, I think something else is used. Okay, but in Jupyter Notebook, you have to use this one percentage PIP install Seaborn. Okay, so that Seaborn can be installed here in Python. After that, you have to import the Seaborn as SNS. As SNS means you can use any other name also. Generally, we use SNS for Seaborn as SNS, so we are using. If you want to use any other variable name, you can also use. Okay, then import NumPy. Okay, as NP, you can use other name also. Then from sklearn matrices import the confusion matrix and classification report. Okay, this classification report must you have to import it. Why? Okay, without classification report also you can just confusion. You can also import just confusion matrix. But why we are using this or importing this classification report? This classification report actually the all reports of this confusion matrix, okay, including this means F1 score, precision, accuracy, everything. All these things are represented by this classification matrix. Okay, just to wait. Let me. Okay, so what are you saying? Yes. So classification. So this classification report basically it includes all the reports that is precision, accuracy, F1 score, everything is included by this classification report. Okay. Then this library, PyPlot and SPLT. You can use another name also. Okay. Then np.array, that is exactly the same example I'm using. What is dog and not dog, what is actual and what is predicted. I have just created two array for that. Okay. After that, I am creating the confusion matrix, actual and predicted. Okay. And after that, the heat map, I am using the heat map, which is included in the SNS. SNS means the Seaborn. Okay. The in Seaborn, so heat map is there in Seaborn. So that is why which we have to include the or import the Seaborn here. Okay. Then, so what is the color codes and everything we used here? Okay, and this is the what is the X level, what is the Y level, and everything means we have created it. And after that, this is the confusion matrix. Now you can see here 5 and 3, 1, 1. Exactly this confusion matrix is created here. Okay, and now you have to print the classification report, actual and predicted. You can see what is the precision, what is the recall, what is the F1 score, and what is the support. Okay, so we need this one. Understood? Accuracy, you can see here, it is F1 score, that is this one for accuracy. Then yes. Okay, so these are the report what you need. After doing that, we need to show some graphs. Okay, so what are the graph? You can create the graph in MATLAB also. You can create the graph in Python also. Okay, that's your matter. Now let me explain the paper. Okay, I think I have given the paper to you, means shown the paper to you before also. Okay, let me show you the paper now. We can also use, we I just need confusion matrix. Okay, it is your duty. Okay, how to make and which software you can use, it is your duty. You can use anything. Okay, the report I have shown that these are the reports we need. Okay, for the paper preparation. Okay, anything, any software you can use, MATLAB, you can use R, you can use Python, you can use anything else. Okay, also C, C++, whatever. Okay, you need, but I need these reports only. Okay. Okay, now let me show the paper. After that, you can understand what are the actual data sets, means reports we need. Okay, so you can see, is the screen visible to you? Screen visible to all of you? Yes. Okay. First, this is the, it is called, it is not a confusion matrix. This is a correlation matrix. Okay. So the data set used here, this data set is for, let me show the name of the paper. This dataset is used for on diagnosis of chronic kidney disease using the machine learning based interface with explainable artificial intelligence. Okay, so the datasets are used for chronic kidney disease. Okay, and of course, chronic kidney disease means only the outcome variables are only yes no outcome, binary outcome variables. Okay, and what are the techniques used here? Let me show you. Okay, writing of paper is not a means easy thing. So you can see, first we need to write introduction. First write down the abstract, then introduction, then literature review. Okay, everything we need to research contribution, methodology. We need everything we need to write. Okay, so I will guide you how to write the paper later. First, you need to arrange the our necessary task, our innovation. You need to first prepare. After preparation, all these things you can use the, you can write down the paper, right? So what are the ML techniques? Okay, these are the features. You can see age, blood pressure, specific gravity, albumin, blood glucose, uh, blood glucose random. Okay, blood urea, serum creatinine, hemoglobin, hypertension, diabetes mellitus, CKD. These are the parameters. Parameters means these are the design variables, which are, that is the independent variables which are used here. Okay, and then there is a, this is the, not a flow chart, there is a process, methodal process of the methodology is a workflow, it is called. Okay, just a presentation how the step wise the works has been done. First, data processing. Okay, arrange the data set, handle the missing values with k nearest imputation. Okay, k nearest imputation is an algorithm to handle the missing values or to find out the missing values. Okay, next, feature selection. Okay, evaluate the original missing values percentage, select input features based on missing values less than 14%. Okay, then model training. So what is the percentage? 70/30 training and testing. 70% for training and 30% for testing are used. Okay, then model evaluation. Obtain the model predictions for the test set, evaluate and predict the prediction and classification. Okay, then classification. Okay, what kind of all the, then model explanation. Okay, explain the best model. Okay, that is which model are the best. ANN. Okay, AHP. Sorry, not HP. ANN means KNN. or the whatever the MML techniques are used in this paper, which model are XVG, support vector machine, which are best, okay, are used there. And then develop and explainable machine learning based user interface to diagnose the likelihood of chronic kidney disease. Okay, so these are the things are done by this paper. So this is a flowchart of the paper, whatever. So this is the matrix. This is not confusion matrix. This is a correlation matrix, just to show that which variables are correlated to each other very nearly. You can see CKD. Okay, so minus 0.72, you can see that is very near about 1. Okay, if the color code is very light, you can see there is a cream color. Cream color is 1, 1 is maximum. Okay, and the minus 1 is minimum. Correlation coefficient always runs between -1 and +1, not more than that. Okay, so 1 is maximum, -1 is minimum. So all values must lie in between -1 and +1. Okay, we need to check that which variables are the highest value, that is near equal to -1 or near equal to +1 values. Okay, near equal to -1 or near equal to +1, they have very high correlation, and that variables should not be considered genuine. So you can see here the cream color, that is very light color, exists only variables. We can see CKD and CKD. CKD, CKD, it is 1. Of course, CKD and CKD will be 1 because both datasets are same. Specific gravity, specific gravity. You can see 2 2 cell, the second 2 2 cell, the second diagonal element. Because specific gravity, both are same, both dataset are same. So since they are same dataset, so of course the correlation coefficient will be 1. Understood? So this is the things which are used. Then I'm talking about these are the models used: DT, decision tree; KNN, okay, k-nearest neighbor; SVC; RF, that is random forest; XGB, and ANN. These are the data sets are used. RF for it is random forest, okay. These are the models are used, ML models, okay. And after using the model, we need to specify this. We need to identify which model is the best fit, or we use the best one. Okay. So how to create this one? Look at this. All this precision, all these sensitive recall, precision, accuracy, F1 score, false positive rate, everything is calculated here. Okay. Then model evaluation. Okay, for testing phase and training phase, both cases, for each and every algorithms, the precision, recall, F1 score, accuracy, FPR, everything is calculated here. Understood? Then confusion matrix. For all cases, the first confusion matrix DT, that is decision pre-training. Second confusion matrix for DT testing. Okay. Second one KNN, KNN training, KNN testing, confusion matrix. Now SVM, support vector machine. Support vector machine training, SVM testing. RF random forest testing and training. XGB testing training. ANN testing training. All the confusion metrics are also created, and you can see by using this confusion matrix, you can see all diagonal elements, there is a reverse diagonal elements having the highest values, and the this one, sorry, diagonal elements having the highest values, and these values, they are the lowest. Next, these are the graphs we need. Okay, these graphs are the false positive and true positive graphs actually. Okay, ROC, it is called receiver operating curves or ROC curves. Generally in MATLAB, the values means um, that is a matrix, confusion matrix, and these ROC curves are simultaneously obtained if you are using MATLAB. Okay, but if you're using the Jupyter notebook, then for ROC curve, you need to create another code. Okay, you can check the Google it, or you can also use the uh, black box AI. Okay, just how to find out the ROC curve. Okay, so this is for false positive rate and true positive rate for testing and training. Okay, X this for XGB, this for ANN for all the processes, all the curves are given here. Remember always, if you can see the curves are almost, it is means this diagonal, that is the upper left side, right? The corner of these curves must fall, okay, just the upper left side, that is in between is 1, okay, near about 1. It should be the near about 1, this phase. Then the curves are means good. Then the you can see these are very means good algorithm. Okay. So input features, indices, accuracy, everything. These are this summarizes means this is a comparison table. Okay, means for different for means different authors for different papers. They are also used these algorithms, but their accuracy and our accuracy is compared here. Understood? Now the explanation means means PDP, that is partial dependence plot and everything. Okay, so this is now these plots. Okay, this is the global explanation for XGB model. Okay, for different each and every value, you can see partial dependence, age, blood pressure. What is the partial difference of age? So these are the graphs for only the design variables, not the outputs. Okay, these are the graphs for the design variables. Okay, partial dependence. So right now, what is your task? All these graphs we don't need. We need the graphs for only these values up to here, ROC. Okay. So we need the confusion matrix for, I'm talking about the classification data set. Okay. For classification, that is categorical data set. Okay. What are the key things we need? ROC matrix, ROC curves, or receiver operating curves. That is RO curves. What is it? It is not ROC. And the confusion matrix. These two things and the all the matrices for confusion matrix, precision, accuracy, and all the things. Understood, everyone? Everybody understood? Okay, so these are your tasks. I think data sets are already shared with you, and if you have your own data set, then you can also things also use that one. Okay, so your next task. Okay, I already explained. So what we need: confusion matrix, all the matrices of the confusion matrix, and the that is ROC. Okay, ROC curves. And also not only for one method. Okay, according to your data set, first of all, random forest, I'm talking about the, if you are having the outcome continuous outcome variable, then regression analysis. Okay, I will go means continuous models. If you are having the continuous model, use the regression, and then I will optimize that one. Okay, how to optimize all I think I have already in the next two classes, 2 or 3 classes, I already have been dedicated to for optimization in MATLAB and optimization in Lingo. Okay, that softwares are already discussed. Okay, so for continuous datasets model, I will give you the optimization techniques. Okay, so your paper has been created with the regression and then optimization. But for these cases means your classification, those who are having the classification model. Okay, what Hello, am I audible? Okay, okay. Just wait. The mail ID will be shared with you. Okay, where to means. Okay, I think anybody else having this issue? There is the mail is not deliverable like this. Okay, multi-criteria decision making table. Okay, okay, yes, yes, yes. For drone data set. Okay, I think I have shared a video also with you for multi-criteria or MCDM technique. Okay, did you see that video? Okay, did you understand something? Is what is MCDM or multi-criteria decision making? Okay, okay. Now you relate to your data set, that is drone data set, how multi-criteria decision making is relate to this. Okay, consent. am.arnova.research@gmail.com or research intensive, or you can use the both. Okay, please note down these two email ID. Okay, both this email ID you can send the your results. Okay, and now whatever you are writing or whatever the analysis you are doing, use that report. Okay, which is the report format is available. The format of the report is available in InnovaWorld dot com means dot in. There already, I think the means link was also shared in the previous class. Okay, download the format, and after downloading the format, whatever the report you are doing right now, okay, write down all the reports in that format. Okay, okay. So anybody else having any question or any issue? Okay, then I'm going to wind up the class now. Right now, the last date is not important. Okay, you can submit as soon as you just means uh, complete your report. You just submit. Okay, both the email ID. Okay, in the report you need to fill the whatever I explained to. Okay, if you are having regression, if you are doing regression, then your final regression model. Okay, you must share the final regression model there. After that, you must share the R square value, adjusted R square value, the P values. Okay, everything you must share that value. And if your data set is categorical, okay, then what to do? Whatever I have explained today, the confusion matrix, okay, all matrices of the confusion matrix and the ROC curves. Understood? All these things you need to share. Right now, I'm not telling you to write down the paper because I need to explain the paper again for you. Okay. Any other question? You can start the neural network model now itself. Okay. Whatever the model you can use. Okay. Okay. For all case of neural network. Okay. ANN. What are the paper I shared? What are the techniques I already shared with you? Okay. The techniques are XVG, neural network, support vector machine. Okay. Random forest, decision tree, and that one. Which one? There is a mm, uh, logistic regression. Okay. So you can use all the models. After doing all the models, or after means getting all the outcomes of the model, you can use this. Where now you have to find out these matrices. That is the confusion matrix, matrices of the confusion matrix, and ROC curves. Okay, matrices of the confusion matrix and ROC curves are obtained, can be obtained for all the means ML techniques. Okay, for all categorical data. So you can use as much as possible if you have the knowledge, or if you means all right now in Google, just Google it, the Python code for ANN or XVG, or that is support vector machine or random forest, you can easily you can get it. Okay, so just get it from the Google. Okay, if you are having any issue, then you can tell me. I will explain it in the next class. Okay. Otherwise, as much as possible, as much whatever the ML techniques you know, use that ML technique, because depending on that techniques, your paper, the innovation and the weightage of your paper depends. As much as techniques you compare, your paper weightage of your paper will be increased. Okay, so high chance of publication. Okay, it's in good journal. Anything else? Okay. Then I am ending the class now, winding up the class now. Good night, everyone. Thank you for attending my class.